Hey everyone, here's our first example problem for chapter 7. So example 1 says a force of F equals 16x squared plus 2x causes a 4 kilogram object to move from x equals 2 meters to x equals 5 meters on a horizontal surface. And so the first part of the question, is asking what is the work done by the force on the object? So when I think about the work being done by the force on the object, the first thing I need to think about is, do I look at this as a constant force or a non-constant force? Since the force is given in the form of an equation, this tells me that my force is non-constant, and that tells me I need to take the integral of the force to get the work done. So for question A, we're going to say that the work is equal to the integral from the initial position to the final position of fx dx, which when I plug in all the numbers for the actual problem, I'll get that the work is equal to the integral from 2 meters to 5 meters of 16x squared plus 2x dx. Okay, so now remember, when we take the integral of any function x to the power of n, that's going to equal 1 over n plus 1 times x to the n plus 1. So when I take the integral of 16x squared, that's going to give me 16 over n plus 1 is 3, so 16 over 3 times x to the power of n plus 1, which is 3, plus 2x is going to be 2 over, this is x to the power of 1, so 1 plus 1 is 2, so 2 over 2 times x squared, and so that just becomes 1. And so then we'll evaluate that from 2 meters to 5 meters, which basically means first I'm going to plug 5 in for x, and so I'll do 16 over 3 times 5 cubed, plus, this I'll just leave as 1 like I said, so I'll get plus 5 squared. And then I'll subtract from that, I'll plug in 2 for x. And so then I'll do 16 thirds times 2 cubed plus 2 squared. And when I do all of the algebra, that will get me that the work that's done by that force is equal to 645 joules. Okay. So now question B is asking, what is the change in potential energy of the object? So remember, when we're talking about potential energy, that's focusing on configurations of the system or the position of different objects within the system. There's no indication that there's a spring in this system, so there's going to be no change in elastic potential energy. And there's no indication of any change in vertical position. So that tells me there's no change in gravitational potential energy. So we can say that since there's no indication of any changes in vertical position or stretch or compression of a spring, or no other change in configuration of the system, that the change in potential energy of the system is going to be 0 joules. So now when I look at part C, where it asks for the speed of the object at x equals 5 meters, if the velocity at x equals 2 meters was 4.5 meters per second, here I'm seeing that the change within the system from this work being done is a change in velocity of the object. And so since there's no change in elastic potential energy or gravitational potential energy, I can think about the work kinetic energy theorem, which says that the work that's done on the system by a force is going to equal the change in kinetic energy of that force, since again, no other energies are changing due to that work being done. And so that will equal the final kinetic energy minus the initial kinetic energy, which we can say is equal to 1/2 mv final squared minus 1/2 mv initial squared. And so I can say that 645 joules is equal to 1/2 of 2 kilograms times v final squared minus 1/2, oh, I'm sorry, that's 4 kilograms. I skipped ahead a little bit. 1/2 of 4 kilograms times v initial squared, which is going to be 4 meters per second, or 4.5 meters per second. And then we'll square that speed. And so then I'll get that 645 joules is equal to 2 kilograms times v final squared minus 2 kilograms, well, 2 kilograms times 4.5 meters per second squared. That all ends up being about 40.5 joules. So then I'll add the 40.5 joules over and get 685.5 joules is equal to 2 kilograms times V final squared. And then when I do all the algebra, I'll find that V final is equal to about 18.51 meters per second. So there you go. That's our first example.